Hi everyone, welcome to our third video of the location strategy series. Today we are going to look at another method. I think just as a reminder, last time we did the previous video was about factor rating as a location method that a company can use. I'm not gonna have the time to go through whatever we did last time, but feel free to watch the previous videos so that you'll understand. Actually, my advice is watch this video in a sequential order, so on the order by which they are posted. Don't start with video 3 if you have not yet watched 1 and 2. So that will really be my advice into this series. Now let's go back to what we're doing. Now today we are going to do the location cost volume analysis. So the location cost volume analysis is a little bit complex because it involves a little bit of some graphical drawings, especially to get your answers. It might be tricky, so yeah, but I hope that if you don't understand, you can still watch this video as many times as you want, or feel free as well to write us an email, and we'll try to explain as much as we can as well. Now when it comes to the location cost and volume here, it is mostly a method that is inspired by the break-even analysis. I think on one of the old videos about capacity planning we touched the break-even analysis, but we'll do it again here. So the cost volume analysis, this is generally an analysis that is conducted when you know it is not about the factors anymore, but this is about you knowing how many units I'm going to produce as a company and how much is it going to cost me. So it's actually a method that balances the production and the cost. That's why it's called cost volume. So I'm looking at how much I need to produce versus how much it's going to cost me, and this is how you go. So generally the objective of this method is to minimize the cost of production, while the factor rating is mostly to maximize the location that is going the factors that we consider the most. Now let's take an example. I think as much as we have this statement here from the book, well, you can just read the steps on the screen, but let's take an example. I believe with example things they make more sense. Now let me see which one we can do. Let's try. Okay, this is still the same. Okay, this is still factor rating. Yeah, let's look at 8.16. It looks like it's a factor rating method. It's a cost and volume. So it's saying that the fixed and variable cost for free optimal manufacturing plant for a right and share weather are shown. So we have the different locations. So with the cost side volume, generally you are given different site, and based on the different site you are given different costs that will be incurred. And I think by now you know that we always have two types of cost. We have a fixed cost and we have the variable cost. A fixed cost is a cost that doesn't change no matter the production. It's like the rent. Whether you are using your unit or not, you still have to pay the rent. Whether you are sleeping in your own flat or not, you still have to pay a rent, and that rent doesn't change. Whether you sleep every day there or you don't sleep every day there, if the rent is 6.5 rand, this is what you have to put. Now let's look at the variable cost. The variable cost, now this is a cost that depends on how much you produce. For example, the salary of employees. We believe that if you have one employee and you pay him 1,500 rand, when it comes to this is, let's say this is what you are paying for one employee. When you get 2 employees, it will be 1,500 times 2, which will be 3,000. So that's why the variable cost is a bit different from the fixed cost. The fixed cost doesn't change no matter how much we produce; it's still the same. While the variable cost change with the production. The cost of material is a variable cost. The labor is a variable cost. All of those are just because the more you produce, the more you pay. This is how it works. Now they've given us 3 sites. They didn't give us the name, but we got site number 1, site number 2, site number 3. The perspective is if I go with site number 1, I have to pay approximately 500. In this case, let's refer to 500 rand per year for fixed cost. Consider this as a rent. The variable cost here we paid 11. It's generally 11 rand per unit. And then if we take the second one and everything, so these are the values that we have here. The question is, over what range of the production is each location optimal? So in other words, they are just asking in terms of the range that we have, in terms of the production that we have, which production will make these locations here equally attractive in a way that whether we go for location 1, location 2, location 3, which one will make it attractive. Now, as we go back to this, I'm going to use the same sheet that we used for the previous exercise, but I'm just going to try to use so this one is location costs volume analysis. So as we look at the exercise here, let me try to put back the table first, then we can decide from there. So the very first one is the site. We have site number 1, number 2, number 3, and then let me try to auto fit to content. Then based on that, now we have the fixed cost, and then here we have the variable cost. Now for location number 1, what has been said here is that I need to close this. Yes, so the fixed cost is 5,100, 1,001.7. So I'm gonna work in terms of rand here. 500, I have 1,000, and then this one I think it's 1.7. It just confirm 1,000. Yes, so this one here we're going to have 11, then we have 7, then I think we have 4 this side. Now the very first question that is asked us is like, over what range of product is our location optimal? Now what it means here, they just want to know between bracket, between everything that we are producing, which weight or how much unit do we need to produce so that location 1 is not different from location 2, or location 2 is not different from location 3, and everything. Now because we got 3 locations here, the best method is always to look at if I need to work between site 1 and 2, if I have to work between site 1 and 3, and if I have to work between 2 and 3. Actually, it like 1 and 2, 1 and 3, 2 and 3. Anyways, because 1 and 2 is the same as 2 and 1, 1 and 3 is the same as 3 and 1, and 2 and 3 is the same as 2 and 3. This means that I need to look at the location whereby these alternatives are still the same. Now, in other words, remember the break-even analysis. The break-even analysis we call actually the total cost. Total cost, it is a formula that is quite common, whereby it is the fixed cost plus the variable cost that we multiply by x. X generally is the number of unit. This means that if I take how much I pay per month plus how much I pay every employee times how much I pay that employee per month, my number of employees, I can have my total cost. Now, this is the formula that we will have to use here. The perspective is we need to find a point where by the total cost of site 1 is equal to the total cost of site 2, and vice versa. Now, if I come back here, I'm going to use the same formula. So we're going to work for the first one. So if I look at site 1, what is the fixed cost in this case? The fixed cost is 500 plus what is the variable cost for site 1? It is 11 rand times x. So I need to make sure that this total cost of site 1 is equal to the same total cost as the one that we will use for site 2. This is still the formula. What is the fixed cost for the the second one is 1,000 plus the variable cost, which is 7, and I have x. So what I have to do here, I have to make x the subject of my equation, which will make it to be 11x. Then if 7 turns on the other side, it changes the sign, so it becomes 7x, and then I'll have 1000 minus 500 because it is going on the other side. This is basic numeracy. So 11x minus 7x, which will give me 4x, which is equal to 500. Then I'm going to divide both sides by 4 to make x the subject of my equation, which will give me 500 divided by 4. And in this case here, it means that my value will give me 125 unit. So this means that as a company, unit, sorry. So this means that as a company, as long as I produce 125 unit, whether I'm on location 1 or location 2, I'm still going to spend the same money. It is the total cost. Actually, you can still take this and compare your values just to confirm, but it still give you the same value. So let's call this total cost for site 1. So the total cost for site 1 is going to be equal to the fixed cost of site 1, which we said it is 500, plus the variable cost. The variable cost of the very first first site is 11. That means you will have 11 times 125. And how much do you get here? 11 times 125 plus 500, which gives you 1875. If we take the total cost for site 2, the fixed cost, the variable cost was 1000. So I'm just taking the values that are have here and I replace X by the value that we have identified here, which is 125. I'm just highlighting it here. So I will have plus 7 times 125 here. So I have 7 times 125 plus 1000, which gives you again the same value, which is 1875. So this means as long as a company is producing 125 unit, there's no difference between site 1 and site 2. So we're going to use the same principle to work between site 1 and site 3. So I'm still going to take this information here. So remember the fixed cost here was 500 plus 11 plus X. Let me go back now to my third site. It's 1.7, which is the fixed cost, and the other one is 4. Then I'll have 1.7 500. 1.7 plus 5. Is it 5 or 7? I think it's 7. So, oh yes, 1700. This is the fixed cost plus 4. Sorry, plus 4 here. So this means that I need to find a point whereby this value, the total cost of of site 1 is equal to the total cost of site 3. In this case, the principle is still the same. I'm going to make X the subject of my equation, which will be 11X minus 4X, which is going to be equal to 17500 minus 500, which is still basic numeracy. Then we will have 7X, which is equal to 1200. Yes. Then you divide both sides by X. Let me make it like this. Yes. So you divide both sides by X, which will give you 1000 divided by 7, which gives you 17,171. I'm going to keep it to 2 decimal places, or let's just keep 1 decimal places, which will give you 71,5, like this. Now this means as well that if I'm producing this amount of unit, I'm not going to do the demonstration like I did in the previous one here, but feel free to do that, and you can even leave it in the comment section to confirm. But that is the principle. So the principle is we have 11x, that one moves down here 1.7, and then you have 5. Then we divide both sides by X, which gives us something like this. Actually, 7 divided by X, 7x divided by X, and then you have 1200 divided by 7, which gives you the 171,5. And then the last one now, so let me highlight it a little bit like this so that we know that this is 1 and 2, and as we go up here, this is 1 and 3, and then this other one is 2 and 3. So 2 and 3, the principle is still the same. So we're going to work on the total cost equal to the variable cost and everything. So what is the total cost for unit 2? The fixed cost. The fixed cost is 1000. I go back to my calculation, and I'm going to replace 1000 times the total cost for this one. It is I think I saw 7x. I go back here. Yes, it is 7x, and for the third side is 1.7 plus 4x, which is what we already have. Again, we make 7x the subject of our equation, which is 7x minus 4x, which is equal to 17 minus 1000. This means in this case that I'll have 3x, which is equal to 700. And then if I have to make x the subject of my equation, so if I need to make x the subject of my equation, I have to decide to divide both sides by 3, which is 7,000. Then I divide by 3, which is supposed to give me a value of 233,33. 1,3. We're still sticking to one decimal place. Now, what does this mean? This means the question is asking us that over what range of production is each location optimal? So the range of production here just means that if we need to look at, if I'm producing 125 units only, then 1 and 2 is the optimal. There's no location that is going to be best. All of them will be equal. If I'm producing 171 unit, 1 and 3 will still be the same. And also if I'm producing 125, 1 and 2, there's one up, 1 and 2, 1 and 3, which is 125, and the last one, it is 2 and 3. So this is how you answer your first question. Now the second question, which is part B, it is a little bit, this one will require a little bit of some drawing. Now, how do we go about that? This is question 2. The very first thing that we need, the question here is asking that if we need to produce 200 units, which site is going to be best? Then what we have to do is we go back here, we identify our equation. Remember, this is the equation. Total cost equal fixed cost times variable cost and everything. Now what I'm going to do here is I will have this, let's say site 1. We will calculate first when it comes to site 1. So when it comes to site 1, what we do have is fixed cost is equal to this. Then what is the fixed cost for the very first item? At 500 plus 11x. So I have 500 plus 11x. Now keep in mind here that they are saying that if, so we are talking about if x equal to 200 units. So this means that we will have 500 plus 11 multiplied by 200 units. This is what we have here. Then what we will have will be 2.700. So this means that if site A is producing, where are we right now? Yes, if site A is producing 200 units, this means that the company is going to benefit something like 2.7. This is not benefit, I mean, this is what is going to cost the company, 2,700. Then we go to site 2. Site 2, this is site 2 like this. The formula is the same, fixed cost plus variable cost. Let me look at the fixed cost, which is 1,007. So here we'll have 1,000 plus x, which is equal to 7. That means we have 1,000 this side, and then we have 7 times 200, which in this case is going to give us 2,400. That means that it's going to cost us between site 1 and site 2. If we produce 200 units, site 2 will cost us less, which is 2,400. Now finally, let's look at site 3. So if we look at site 3 in this case, this is the fixed cost. Let me go back and find out the total cost. It's 1.7 and 4. So here I have 1.7, 500, and then I have a value of 4. This means I have 1.7, and then this one I have 4 times 100. So if I take 4 times 100 plus 1.7, then I'll have 2,500. So this means that if we have to produce 2,000 units, site 2 will be the cheapest, followed by site 1, and then we have this other one. But obviously we need to see generally in terms of range and everything, because the question here is that for a production of 200 units, which site is going to be the best? So obviously, if we need to produce 2,000 units, how do we call this? the location that will be the best is going to be this side. Why? Because it is the cheapest. But then we need to identify as well the range to know that between this production here, which range is going to be best. But based on such calculation, I wouldn't want to do it to make the video a little bit longer, and it is not part of the question at this point. But I think in our next videos we'll probably be able to, if you find a question like that, we'll probably make that video. We should make a little bit longer, but it will be quite interesting. So let me go back. Yes, so with that said, we have done question 2, we have done as well question 1, or we have done A and we have done B as well. Then in this manner we are done with the cost and volume method. Have a great day, take care, and we will stay in touch. Don't forget to subscribe to the channel, like, and leave a comment.